Hello guys, in this video I am going to explain the solution of this question of 5.1, which is a practice problem of this book Engineering Circuit Analysis by Hayt, Kemmerly and Durbin, and the problem is related to superposition theorem, right? And it is of chapter 5. So the question says that we need to determine the current Ix using the superposition theorem. And with superposition theorem, we know that if there is a superposition theorem, then we need to activate only the one source and we need to deactivate all the other sources. So as in this question, we have two independent sources. So this means that we will be having two cases. Case 1, in which we are going to keep this 2 ampere as active and this as deactive. And in the second case, we are going to keep this 3.5 as active and 2 ampere will be deactivated, right? So in the case 1, if I draw the circuit for case 1, then this circuit, it will be, we keep this 2 ampere as active, so it is 7 ohm, it is 3 ohm, this is 15, this is this, and since this 3.5 it is a volt, so we know that when we deactivate this voltage source, it will be replaced with the short circuit, right? So we get this. And now since in this circuit, now this is Ix1, so now in this question, since this 5 ohm, this is short circuited by this short circuit path, so simply all the current, like whatever current is there over here, all the current will just follow the short circuit path. So it means that the role of this 5 ohm, it will not be there. So our circuit will be something like this. So this is the circuit for case 1. For the case 2, where we are going to keep this 3.5 as active and we will deactivate this 2.4, which is a current source. And we know that deactivating the current source means that we will replace it with the open circuit. So our circuit, it will be something like that. We will just open it. Then we have the two resistances, it is 7 ohm, it is 3 ohm, then we have this, it is 15 ohm, then this 5 ohm, and then a battery which is this 3.5 volt, and let this current, let it be Ix2. I keep the direction of this Ix1 and Ix2 in the same direction, so that whatever value we are going to get for Ix1 and Ix2, simply we will get the value of Ix as Ix1 plus Ix2, right? So now if I solve this circuit of case 1, so over here the equivalent resistance for this, it will be like 7 plus 3, the equivalent is 10. So 10, this 10 ohm, it is in parallel with this 15 ohm, right? So the equivalent resistance for this R equivalent, it will be 15 into 10 upon 15 plus 10. So if you solve this value, so you will get it as 6, right? So this 6 ohm, it is in this 6 ohm, it is something like this, that it is 6 ohm and we have this, right? So it means that this current is going to flow in this direction, plus and minus will be over here. So the voltage across this 6 ohm resistor, it will be current into resistance, so we have 12. So it means that the voltage across this 6 ohm, which is equivalent resistance, it is 12 volt. So it means that across this we have this 12 volt, right? So what we did overall, we simply determined the equivalent resistance of this 15, of this 7 and 3, and the equivalent resistance is this 6 ohm. Then we determine what is the voltage drop across this 6 ohm. Since we have a current of 2 ampere that is flowing through this 6 ohm, so we get that the voltage across this 6 ohm, it is 12 volt. And since this 6 ohm, it is simply the voltage, this 6 ohm, it is the equivalent resistance of this resistances, so it means that 12 volt will be dropped across this 7 and 3 ohm. Also the voltage across this 15 ohm, it will be 12 volt, because this 15 ohm, it is in parallel with a series of 7 and 3. And since we get the voltage across the 15 ohm, since the voltage is 12, so it means that the current ix1, it will be equals to voltage divided by resistance. So 12 divided by 15, so it is 4 by 5, it is 0.8 ampere or 8 milliampere. So the current flowing through this, in case 1, it is 800 milliampere. So let me substitute it over here, milliampere plus. Now coming to circuit case 2. In case 2, since we have this open circuit, so simply we can remove this open circuit to simplify the circuit. So our circuit is like this. Now over here, this 3.5 volt, it is in parallel with this 5 ohm. Also this is in parallel, this 3.5 volt, it is in parallel with a combination of this series combination of these 3 resistances, 15, 7 and 3. It means that the voltage drop across this series combination of 15, 7 and 3, the voltage drop is 3.5, right? So the overall voltage across this, like this is 15, 7 and 3, right? So if this is 15, 7 and 3, so the voltage drop across this, it is 3.5 volt, because this branch, like this branch, it is in parallel with 3.5, right? So since we know 3.5, so we can determine what is the current. So current will be voltage divided by R equivalent. R equivalent means the combination, the sum of these 3 resistors. So it means 3.5 divided by 15 plus 7 plus 3, and it is equals to 3.5 divided by 25, so 0.7 divided by 5 or 0.14 ampere or 140 milliampere, right? Now if we look at the direction, now this is just the magnitude, we also need to check the direction. So now over here plus sign is at this point, minus is over here, so the current, the direction of the current in this, it will be in this, right? So the current that is flowing through this 3.5, it is in opposite direction to the, it is in opposite to the direction of ix2. It means that our ix2, it will be equals to minus of 140 milliampere. So the current that we got, 140 milliampere, its direction, since the direction is opposite to ix2, so we take it as minus. How we get that it is opposite? From this one, because the voltage across this 15, 7 and 3, the voltage drop across this 3 resistor, it is 3.5, and plus is over here, minus is over here, so our circuit is like this, right? Our circuit is like this. So if we simply, so the current direction will be like this, which is opposite to ix2. So our ix2, it is minus 140 milliampere. So if we substitute this over here, so we get minus 140 milliampere, so it is 660 milliampere. So our current, it is 660 milliampere, which is also given over here. So this is the solution to this question. So if you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.